Unmute. Let's try that. All right, so number 6 asks us to use a theorem to explain why the given triangles are not possible. So this goes back to what we know about triangles that do not have any congruent sides. So we should have the longer side is opposite the largest angle. Smallest side is largest, the smallest angle. So what we need to do here is we need to figure out what the measurement of angle B is. So I'm going to take the total interior measurements, the sum of the interior angles of a triangle. Actually, let's do this. So 37 plus 63, I think is 100, right? So 180 minus 100. So take the two that I know. And so that means that angle B is 80 degrees. However, if that were the case, then that would mean that my largest side would be opposite the 80 degrees because that's my largest angle. So because of this, this triangle is not possible. I cannot have a smaller side opposite my largest angle. So this is because of the greater angle theorem. So we could say that the longest side, which is AB, equals 11, must be opposite the largest angle measurement because of the greater angle theorem. Excuse me. So because it's not this, like, physically is not possible. It's not possible for this, the medium side, the 10 unit side, to be opposite that largest angle, angle B. All right, so the next one, sorry, it's a little wonky. I did my best to get them matched up. It didn't quite work. So in the next one, we have an exterior angle. So this is probably going to be working with the exterior angle theorem, exterior angle inequality theorem. And so let's look. What do we know about the exterior angle and the two remote interior angles? Right. So the sum of the remote interior angles must equal the exterior angle. Like, it will always be exactly the same measurement because the sum of a linear pair, which in this case is the 41 degrees and then that interior angle A, has to equal 180. And all the interior angles of a triangle must equal 180. So that means that 15 degrees and that 20 degrees, if we add those up, they should equal 41. But when we add them, we find that they only equal 35. So if they equal less than the 41 or more than the 41, it's impossible because of the exterior angle inequality theorem. So these are not possible because the remote angles equal 35 degrees instead of 41 degrees, which is what they're supposed to equal. So that's why this triangle is not possible. All right, so now we're sort of pulling, I think most of these come from 5.3 and 5.5. The inequalities section with the greater angle theorem, the longer side angle theorem, and the exterior angle theorem, and then 5.5, where we have some of our other inequality theorems. All right, so looking at the diagram that we're given, why, okay, so what we know that they tell us something here. So mx is congruent to, not that one, jx, like this whole this whole thing added together. I'll just put it right there. All right, so MX and JX are congruent. They're exactly the same length. So why is JQ have to be smaller than MQ? So let me get my highlighter here. Is it small? Nope. So they're telling me in this first one that JQ has to be shorter than MQ. So in this case, we have, see if I can figure out how to show this so it makes sense. Let me look at, so the triangle that contains JQ is this one here. The triangle that contains MQ is this triangle right here. So looking at this, both of these triangles share a side. They share that QX, and they share JX and MX. Well, sorry, they share, or we know that those are congruent. I'm sorry, MX and JX are congruent because they told us that. So what we have to look at, figure out how to do this, is we know that the angle, this angle here, the included angle in the teal, the aqua triangle, MXQ, that includes angle JXQ. So obviously that included angle, this is the hinge theorem. The included angle is smaller in JQX than it is in MQX. So we look at our opposite sides. So this one, the opposite side is MQ, JQ. Well, obviously the angle for MXQ is much bigger than it is for JXQ. So this is the hinge theorem. Or, hold on, let's go back. Let me look at this. Where's the greater? Two sides of a triangle are not, okay, so yeah, so in this case, we have congruent triangles. So that's why it has to be the hinge theorem. The hinge theorem says if two sides of one triangle are congruent to two sides of the second triangle, and the included angle of the first is larger than the second, then that third side of the first has to be longer. So this is the hinge theorem. So if you're working, two of the triangles are congruent and the third is not, that's your hinge theorem. If it's a scaling triangle and they're all completely different sizes, that's when you look at your greater angle theorem and your longer side theorem. All right, I'm gonna clean this up a little bit. Okay, so for the next one, they're telling us that the measurement of angle MXQ, so that is, okay, this one here, is greater than the measurement of XQM. There's XQM. This one here. So in this case, because we're looking at kind of the same triangles here. We have, hold on, let me get my curve straight. We still have a congruent side. And measurement MXQ, XQM. Let's see. Did I mark it right? XQM. So what do we know about these angles? We're working in triangle MXQ. let's see. Is it a, this looks like the greater angle theorem. Because in A, we know that we have our longest side. So the largest angle has to be opposite the largest side. So this one here is the largest side. So it's got to be opposite that interior angle, the largest angle. So this would be the greater angle theorem. All right, so go back to section 5.3. 5.3 says if two sides of a triangle are not congruent, so this is when you're working in just one triangle. So if two sides of a triangle are not congruent, the larger angle is opposite the longer side. So yeah, this is the greater angle theorem. All right, so the next one says the measurement of angle JQX, so that's this guy here, is smaller than AXJ, which is this one. So these two angles together, if we look at triangle XJQ, get it highlighted here, you'll notice that my first angle, my smaller angle, is an interior angle to that triangle, and the other one is an exterior. So angle XQJ is a remote interior angle, and angle AXJ is the exterior angle to this triangle. So this one is the exterior angle inequality theorem. All right, let me get this switched over. So it fit. Y'all might be able to. Exterior angle inequality theorem. Okay, so for the last one, MQ is less than the sum of MX and QX. So MQ and X is this triangle right here. So because right now we're looking at side lengths, and we see that there's an inequality in the length of one side and the sum of the other two, then we've got to go back to 5.3, inequalities. If two angles of a triangle are not congruent, the longer side is no. That would be where one side has to be less than the sum of the other two. Maybe comparison? Oh, it's just the triangle inequality theorem. It doesn't have anything to do with the, there it is. So the triangle, triangle inequality theorem just means that no side can be larger than the sum of the other two. Yeah, that's from section 5.5. And that's where we were playing with the triangles. And sometimes if they're too small, then they don't meet. Other times when they're equal, then they're collinear points. All right. All right, so now we're moving into section 5.4, and this is the one related to indirect proof. So if you were struggling with the indirect proofs on the last two quizzes, stay with me. All right, so write the initial assumption for an indirect proof of the following statements. If a car has anti-lock brakes, it will not make skid marks on the pavements. So what does that initial, sorry, your initial assumption takes your conclusion and negates it. So the conclusion here is that the car will not make skid marks on the pavement, and so we negate it. So we would say that we need to assume the car made skid marks. On the pavement. This is that very first step of every indirect proof. You negate the conclusion and then treat that negation as if it's true and tell me what it proves. Then compare it to your given. All right, BD is the median of triangle ABC. So for this one, we would say that BD is not the median of triangle ABC. All right, this one, I really need y'all to try to focus because there's a lot of this on the quiz and it could be very, very confusing. But there's one point that I need to make clear as we go through these. So stay with me. All right, so in this case, classify each pair of statements. Tell me if they are neither contradictions nor negations. They are both contradictions and negations of each other, or they contradict, but they do not negate. So they're not the opposite of, but they do contradict the original statement. All right, so for A, n is a positive integer, n is not a positive integer. So does that contradict? Yes. Does it negate? Yes. Numbers can either be positive or negative. Oh, shoot. Technically, it could be 0, which is also neither positive or negative. But we're not going to go with that. In this case, a number is either positive or negative. Okay. Maybe we could say 0 is only positive. It's only positive. You can't have a negative 0. Okay, we'll just go with that one. So this one would be both a contradiction and a negation. B. Okay, how about our second one? Triangle ABC is an isosceles triangle. Triangle ABC is an equilateral triangle. Can a triangle be both isosceles and equilateral? Is a equilateral triangle also an isosceles triangle? Sure. Yeah, isosceles triangle has two congruent sides. Does an equilateral triangle still have two congruent sides? It still has two, it just also has a third. The isosceles triangle does not take into effect that third side. So if we state that something is isosceles, then that means that the base is not congruent with the other two. If we state something as equilateral, the other two sides are still congruent, but it also means the third one is as well. So an equilateral triangle would also be isosceles. So this one is neither a contradiction nor a negation. All right. Triangle ABC is acute. Triangle ABC is obtuse. Do they contradict? Do they negate? No. Why does a triangle being obtuse not entirely negate the fact that it's acute? Well, but it's defined by that one obtuse. What's the other kind of triangle we can have? A right triangle. So the only thing that fully negates a triangle being acute is to say that ABC is obtuse and right, or obtuse or right. So for something to both contradict and negate, you must negate all options. Like you must state all other options. So it's the trichotomy property. So that's why this is a C. It's a contradiction, but it is not a negation. H. There's an H there. Look at the trichotomy property. Trichotomy. So again, if I say that X is greater than 0, to negate that, I would have to say what? X is less than or equal to 0. So there's 3 possibilities: greater than, less than, or equal to. So anytime there's a possibility of 3 and your second option does not include the other 2, you're looking at a contradiction but not a negation. All right, what about this last one? Lines M and N are skew lines. Lines M and N are coplanar. Remember these? So the definition of skew lines is that skew lines do not exist on the same plane. And coplanar means that 2 lines exist on the same plane. So you see we have a either or option. We have 1 or 2. So that's why this one is both a contradiction and a negation. So to say that 2 lines are skew lines, literally by the definition of skew lines means they cannot be coplanar. That's the only definition. They do not intersect because they are not coplanar. So this would be a B. It is both a contradiction and a negation. Okay, let's practice writing an indirect proof. Given that GE is the altitude of triangle DFG and DE is not congruent to FE, prove that angle D is not congruent to F. So the first step of an indirect proof, we assume the opposite of our conclusion. That's our conclusion. Try to find it. While we are proving the opposite of the negation of our conclusion, we ignore our given, in the sense that we don't use it as much of it in our definition. However, you need to look at it to find out what you need to find an argument against. So obviously, we're going to end this with DE being congruent to FE, because that's what we're trying to contradict. We're trying to prove that would be true. So words are hard. Let me just show you what I'm talking about. So first, we need to assume that angle D is congruent to angle F. All right, so if that's the case, let's go over here. Angle D is congruent to angle F. So we know that if it's an altitude, it is perpendicular to DE and EF. But the fact that it's an altitude tells us absolutely nothing about where it lands on that line DF. It's not necessarily at a midpoint. But it is a right triangle. So that tells us that angle, let's go. So angle DEG and angle FEG are right triangles, or excuse me, right angles. That also means that they're congruent, but we're working with a right triangle. We also know that side EG is congruent to side EG because of the reflexive property. this is congruent. So if we look at that, thinking about our right triangle properties, we have an acute angle and we have a leg in two right triangles that are congruent. So we can state that triangle DEG, DEG is congruent to triangle FEG because of the leg angle congruency, because we have right triangles in here. Now, if that's the case, let's go back to what we were trying to prove. So this is where our given comes into play. So if I look at, based on this proof, based on I assuming that angle D is congruent to angle F, that would mean that DE would have to be congruent to FE because they're corresponding parts in each of these now congruent triangles. So because I've proved the triangles are congruent, I can say that DE is congruent to FE because corresponding parts of congruent triangles are congruent. So there's my assumption, and using that assumption to prove a part, if that assumption were true, then this would have to be true. However, my given is, think of that as like your absolute truth. So we could say, but we know that DE is not congruent to FE because it was given. Therefore, angle D must not be congruent to angle F. That should look somewhat familiar from the quiz that you just took as well. All of these are pretty similar. All right, staying sides. This is probably also has to do with 5.5. All right, use a theorem to explain why this triangle is not possible. Anybody want to take a quick guess? Anybody see it?
Yes.
Why? PQ and QR are not long enough. So stay with me on this one, all right? This is that section 5.5. The triangle inequality theorem says that the sum of two sides has to be greater than the length of the third side. So when you look at this, you're looking at your side lengths. They didn't give us any angles, so we have no idea. So we're just looking at sides. So the triangle inequality theorem tells us this cannot be possible. Because 19 is not less than 6 plus 10. Here, 19 is not less than 16. And it would have to be in order for this to actually make a triangle. So that side with the 6 either needs to be greater than 9, or the side that's the 10 needs to be greater than 13 in order for us to actually be able to make a triangle. And these don't. Okay. Moving on. So again, this is more with the triangle inequality theorem. Identify the results of attempting to construct a triangle with the given side lengths. This again. A lot of y'all missed these because you didn't have the notes. So let's look at this. So take your longest side. In this case, it's 16. 16 has to be less than the sum of the other two. Is 16 less than 15? No. Is it equal to 15? No. they're not even close. So this would mean the segments do not meet. All right, let's look at the next one here. Our longest side is 25. So 25 has to be less than 13 plus 19. What is 13 plus 19? So it's 20 plus 12, so that's 32. All right, so is 25 less than 32? Yes, so what does this make? A triangle. It makes a triangle, yes. Oh yeah, I forgot to put your options. It's either the segments don't meet, it makes a triangle, or they're collinear points. They just make a line. All right, so this last one, our longest side is 58. That needs to be less than 35 plus 23. Let's see, so 58. 5 plus 3 is 8. 3 plus 2 is 5. So is 58 less than 58? What happens when they're the exact same number? They are all they just make points on a line, so they're collinear points. Okay. All right, find the range of possible lengths for the third side of a triangle with two sides of the given length. I always just draw a triangle. You don't have to necessarily. We're just using the same formula we just did before, but I like to have the picture here. I'm gonna draw myself a little triangle. This one's 4, this one's 7. I don't know what this guy is. So we write two different inequalities because we need a range. That side can be as short as one length or as long as the other. And that's the range that it can be. The first one is I take the longest given side. So 7 has to be less than x plus 4. And as one side. And then x also has to be less than the 2 that I know, which is 7 plus 4. So there's my two inequalities. So in the first case, I subtract 4 from both sides. And that tells me that x has to be greater than 3. This is a conjunction, so I got the other side. In this case, x has to be less than 11. So when I put that as a combined statement, x has to be greater than 3, but less than 11. The other one, you can practice on your own and see how you do. I might get to it if we have enough time in class, but we're only sitting at about 10 more minutes right now. Are we almost done? Yeah, we're close to being done. All right, so for 14, find the range of possible values of x. What theorem are we going to use to determine the range of these? Sorry, it's still there. I'm just moving on. So we've got two separate triangles, so we're looking at either the hinge theorem or the converse of the hinge theorem. Now, the hinge theorem has two triangles, but it also means that we have two congruent sides. Do we have two congruent sides? Sure. They share one, this guy right here. And the included angles are the ones that they gave us. So I need to find the values of x. What do I know about these two sides? I know that 2x plus 3 is greater than 3x minus 2. Because there's my angles. Which one's the larger angle? 70, right? So I'm going to take my sides. To find one range, I'm going to take 2x plus 3 is greater than 3x. 3x minus 2. And then we just solve. So I'm going to subtract 2x from both sides to keep my x value positive. So 3 is greater than x minus 2. And then when I add 2 to both sides, I get x has to be less than 5. Now, we also, the second part, this is the first part. The second part of this is you always assume the smallest side is at least greater than 0. That's how you find the other end of your range. So our smallest side is the 3x minus 2. So 3x minus 2 must be greater than 0, whatever that length is. So what is the value of x? So we just solve. So we add 2 to both sides. 3x is greater than 2. And then we divide both sides by 3 so that we know that x has to be greater than 2/3. There's our range. X is greater than 2/3, but it must be less than 5. Sorry, let y'all get that. Again, if you're missing any of it in class, this video will be up as soon as class is over, so you'll be able to find the part that you missed and kind of look at it again if you have any trouble. It doesn't make any sense. All right, so for 15, we're going to use the hinge theorem or its converse to compare an unlabeled pair of sides or angles in each pair of triangles. Again, very, very similar to what you just did on a quiz. Now, they're giving, oh, I must have forgotten to write it down, so I'll give it to you here. So they're giving us information about our two triangles. So in this case, they're telling us that UM is less than IY. So if UM is the smaller, just make that S, and YI is the larger, or if you want, you can just give them a number. Make one 8 and the other one 10. Then what does that tell you about the included angle? So these are congruent. 5 is congruent. 5 is congruent to 5. 6 is congruent to 6. Just make this a bit bigger. And they're telling us that UM is the smaller of the two. So we need to look at the angles. That means that angle F is a smaller measurement than angle Z. So we would say angle F is smaller than angle Z, or is less than. All right. So for this one, I'm going to say that angle A, so add this next to B, because I apologize, I forgot. Angle A, I'm going to use measurement, it's going to get weird. Measurement of angle A is greater than the measurement of angle X. So A, this one's the larger, X is the smaller. So what sides do we compare here? WJ and BE. So WJ is what? Side WJ is what compared to side BE? It's greater than. The larger angle gives us the longer side. The smaller angle gives us the shortest side. Opposite. Is that it? I think that's it.